If you have ever looked at a white light being shined into a prism, the main thing you probably noticed is it being turned into a rainbow. However, did you notice that the light didn't travel straight through the prism? The light changes direction when it enters the prism, and it changes again when it leaves. This bending of light isn't something that's unique to prisms. It's a common occurrence in translucent and transparent materials. We have even come up with unique names for the angles at which the light enters and travels through the material. The angle at which the light enters is called the angle of incidence. The angle of incidence can be defined as the angle between the oncoming ray of light and the normal vector of the surface of the material it is coming into contact with. The normal vector is a perpendicular vector from a plane or surface of an object. There are three possibilities for what can happen to the light after it comes into contact with an object. The first is absorption. In absorption, the light ray travels no further. It is taken into the object and transformed into energy. This most often takes the form of heat. The second is reflection, where the light ray is bounced off the material instead of absorbed. The final possibility is refraction, in which the light penetrates the object, but instead of being turned into internal energy, it changes direction and continues to travel through the material as light. It's important to note that light does not often do just one of those three possibilities. Rather, it travels in a combination of them. For example, we see color because objects reflect the visible light spectrum of the corresponding colors we see back to our eyes, but they absorb the other wavelengths of the visible light spectrum. Another example would be translucent objects. A translucent material, as opposed to a transparent one, only lets some of the light travel through it and absorbs and reflects the rest of it. With absorption, there are no further relations between the angle of incidence and what happens to the ray of light, but with reflection and refraction, there's more to learn. The relation between the reflected light ray and the incident light ray is governed by the law of reflection. The law of reflection states that the angle between the reflected ray and the normal vector is equal to the angle of incidence. Mathematically, this is expressed by the following simple relation. Theta I equals theta r. Theta I is the angle of incidence, and theta r is the angle of reflection. So, if you know either the angle of reflection or the angle of incidence, you automatically know the other as well. Have you ever been spearfishing or seen it done on television? The fisherman stands in or above shallow water and tries to spear the fish as they swim by. If they try to hit the fish exactly where they see it, they'll miss. The fish is not where it seems to be from above the water. This is an effect of refraction. Light bending as it enters the water is what causes the fish to appear in a different spot from where it actually is. Much like with the angle of reflection, there is also a relation between the angle of incidence and the angle of refraction. When light enters from one medium into another, it can bend to some degree. The calculation of what degree the light will bend is known as the law of refraction, or Snell's law. The degree to which the light bends is dependent on both the incidence angle entering the second medium and the speed at which the light travels through the two mediums. The relationship between the speed of light and refraction is given in the index of refraction. You'll need to understand the index of refraction in order to understand Snell's law. N equals c over v, where n equals the index of refraction, c equals the speed of light in a vacuum, and v equals the average speed of light in a medium. While the speed of light in a vacuum is constant, the speed of light in other mediums can vary, and consequently they have different indices of refraction. Some common examples can be seen in this table. Now that you're familiar with the index of refraction, we could look at Snell's law as defined mathematically. We'll also walk through an example, which requires basic algebra skills and a scientific calculator. N1 times the sine of theta 1 equals N2 times the sine of theta 2, where theta 1 is the angle of incidence and theta 2 is the angle of refraction. Snell's law is what is commonly used when looking for a formula for the angle of incidence. It should be mentioned that N1 is the index of refraction for the material the incident light ray is traveling through, and N2 is the index of refraction for the material the refracted light ray is traveling through. This can be seen visually in this diagram. Now let's use what we've learned to find an angle of incidence. In this example, we'll have an incident light ray travel through a vacuum and then go into a block of ice at an unknown angle of incidence. We know, however, that the refracted ray travels through the block of ice at a 30-degree angle, theta 2, from the normal vector. We can also look at the tables of indices of refraction from earlier to see that a vacuum has an index of refraction N1 of 1, and the block of ice has an index of refraction N2 of 1.31. First, we'll rearrange Snell's law to derive a formula for the angle of incidence, theta 1. N1 times the sine of theta 1 equals N2 times the sine of theta 2. Sine of theta 1 equals N2 times the sine of theta 2 over N1. Theta 1 equals the arc sine of N2 times the sine of theta 2 over N1. Now we can enter the values we know from our given information into the formula to find the angle of incidence. Theta 1 equals the arc sine of 1.31 times the sine of 30 over 1. Theta 1 equals the arc sine of 0.65. Theta 1 equals 41 degrees. So our refracted ray of light will travel through the ice block at an angle of 41 degrees. The angle of incidence can be defined as the angle between the oncoming ray of light and the normal vector of the surface of the material it is coming into contact with. The normal vector is a perpendicular vector from the plane or surface of an object. When light hits an object, three different interactions can occur: absorption, reflection, and refraction. Absorbed light goes into a material and is turned into energy. Reflected light is bounced back off the material. And refracted light changes direction as it enters the material and travels through it while remaining as light. For reflected light, we can see that the angle of incidence is equal to the reflected angle through the law of reflection. With refraction, to see the relationship between the angle of incidence and the refracted angle, we also need to know the indices of refraction for the two mediums the light is traveling through. The indices of refraction, refracted angle, and the angle of incidence are all related through Snell's law. This calculation of what degree the light will bend is known as the law of refraction. When looking for a formula for the angle of incidence, Snell's law is what is normally used.